Greetings. My name is Charles Sven. I started my Richard Feynman-like, start-from-scratch, independent study of cosmology and Big Bang creation in December of 1997. I presented my evolving work at 22 conferences listed at my website, allnewuniverse.com/public talks. Today's presentation is about Edward Milne's 1930s Copernican cosmological principle revisited. You can find extensive discussions about this principle at Stanford Encyclopedia of Philosophy on the web titled Methodological Debates in the 1930s and 1940s. His principle proposed that Earth is not the center of our universe, and as observers, we don't occupy a special place. Further, his principle is a cornerstone of astronomy and is assumed without question, playing an important role in the viability of cosmological models. His Copernican principle, along with homogeneity, served to greatly simplify the number of possible models for the universe in use all the way up till today. We'll start our review in 1514 with Copernicus. Sometime between 1510 and 1514, he sent copies to various astronomers moving Earth from the center of our universe. Continuing our review, now up at December 30th, 1924, Edward Hubble announced he had evidence that the Milky Way galaxy was just one of many galaxies in an unimaginable, ever-expanding universe. This finding of Hubble's galaxies meant that not only did we move Earth from the center of our universe, but possibly into obscurity among all those many galaxies. Bringing our review up to 1989, we note that Joseph Silk said in his Big Bang book, if the universe possesses a center, we must be very close to it, within less than 0.1% of the radius. Otherwise, more radiation would come from one direction than the other. And it does. By 2010, we found more radiation. We reviewed the large-scale anomalies in temperature maps recently found in the CMB, the cosmic microwave background radiation. In this temperature dipole model, Earth is in the center of the sphere. Supporting this dipole anomaly is NASA's COBE satellite, who measured Earth's superfast velocity by Olympic standards, but super slow by light speed standards, just 0.2% of light speed. And here's that same dipole anomaly in the NASA COBE data in a 3D image with Earth virtually in the dead center of the sphere, within 0.2% of the radius. Joseph Silk said that we would detect more radiation from one direction than the other if we weren't in the center. And we did, but just that NASA COBE tiny 0.2%. Supporting evidence supporting Earth's very tiny radiation anomalies are some modern space and earthbound telescope studies. They are Dr. Tegmark's WMAP satellite data, the Sloan Digital Sky Survey of luminous red galaxies, the Anglo-Australian pie graph of quasars, and Hubble's spectacular ultra-deep fields. Starting with the WMAP satellite data, processed by Dr. Max Tegmark, he notes the entire observable universe is inside the sphere, with us at the center of it. The next graph is this Sloan Digital Sky Survey of luminous red galaxies that surround our Earth like we are in the center of a symmetrical donut hole. Move Earth from the center and you distort the symmetrical donut shape of these luminous red galaxies seen by the Sloan Digital Sky Survey. This donut hole distribution is not homogenetic. This next graph, the Anglo-Australian telescope, finds that Earth is in a billion light-year donut hole surrounded by quasars. No other holes found. Again, move Earth from the center and we lose that donut shape seen by these telescopes. And this donut hole is not homogenetic. So here we have that great Hubble Space Telescope's ultra-deep fields, finding opposing north and south deep fields and the cold spot, all over 13 billion light years from Earth. Triangulation of these distances and coordinates fixes Earth virtually in the center of our observable universe. What best supports this very slow Earth central location? An explosion in space or an assumption of space expansion? This is the data that proposed acceleration, the Hubble diagram of supernovas. Accelerating space expansion is a misreading of statistical data. Sometimes using statistical averages can hide significant information, and this scatterplot graph does that. It skips reality and uses the statistical upcurving average that assumes acceleration. The scatterplot is what one would expect to find from an explosion in space. Finding very slow Earth atoms almost blasts out, leaving Earth virtually right next to the epicenter of the initial event, and denies that space expansion assumption. And this scatterplot is not homogenetic. So now, if we don't have homogenetic space expansion or an obscure Earth, what's left is dark energy. The best possible analysis of the initial Big Bang-like event uses unrecognized, up to now, commonplace evidence of dark energy in 3D. Evidence of dark energy on Earth is commonplace. Just strike a match and the ancient atom electrons, pushed by a strong energy force, drive light photons out instantaneously at 186,000 miles per second. But up till today's match study, presented here by me, science has no theory on what drives electrons. Could an atom contain a 13.8 billion-year-old battery? That doesn't seem to be possible. It needs an external source, and dark energy is one that works, and is needed for at least 13.8 billion years. And here's how. The speed of light photons needs ancient electrons moving at the speed of light, driven since the initial event by dark energy that activates light photons when struck. What we know about light photons. From a match, we see the light, painless. But put your finger near the flame and we get burned. Add more light photons from a dynamite explosion and we can blast a hole in rock. Add even more light photons coming from an atomic bomb and we destroy a city. Squeeze atoms in a star's huge gravity field and starlight photons supports life on Earth. What we know about atoms, dark energy, orbiting electrons, and light photons moving at the speed of light. That dark energy has to be very powerful. That dark energy field that powers all the electrons and all the atoms and all the galaxies out to the edge of space for billions of years must be huge, perhaps billions of times the size of our universe, possibly infinite. That dark energy field, running every pattern possible, eventually formed into laser-like beams and converged into a small enough space that combined virtual particles into atoms, exploding out into space. That was the initial event. An example of this initial event is found in an experiment here on Earth. Tiny atomic matter created from huge energy beams reported at Stanford in 1997. So here's my graphic of the initial events. Atoms out, filling all of observable space out to the CMB field. And last out of the initial events, the atoms used to make Earth and the Milky Way galaxy are moving at only 0.2% of light speed, placing us virtually dead center, right next to the initial event's epicenter. So here we go from chaos, dark energy converging to creation, atoms exploding out of the initial events, as we saw earlier. Boom, 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 boom. How a light source moving at light speed is viewed, its emission versus its actual position. In order to see a midpoint of an object moving near the speed of light, what we see is only the fast car's taillight emitted, not the actual far out position. In order to put all this observational evidence together, we must recognize that all we know about gravity is by its observed effects. The same is true about dark energy, driving star atom electrons, lighting up galaxies, observed for billions of years. And with that in mind, we can say, in conclusion, atoms out to the CMB field, the midpoint of its travels takes 13.8 billion years. Add light photons returning from the CMB midpoint to Earth in center, the epicenter of the initial event, take the second 13.8 billion years. This round trip equals the age of atoms. They are 27 billion years old, the elapsed time since the initial event, going from chaos to creation. Light from the midpoint of these 13 billion-year-old Z20 galaxies and 13 billion-year-old CMB atoms surrounding us takes 13.8 billion light years to reach Earth. The title of the full paper where this talk is taken from, presented at a conference last year, 2022 in Prague, is Charles Sven, Chaos to Creation, a 25-year study, and is accessed through YouTube, Google, and my website, allnewuniverse.com videos. This was the last of 65 papers presented at the 33rd Midwest Relativity Meeting at Chicago on November 23rd. Thank you very much for listening to my presentation. I'm available to present this work of mine to your study group or university. And here are some links for your notation.